Welcome back to our machine design series. Today we are diving into the topic of bearings. So let's first define what a bearing is. A bearing is a device that bears a load while allowing motion that is inherent to the machine. So for example, bearings on the axle of train wheels bear the load of the train, so the weight of the train, while also allowing motion of the wheels. They're allowed to rotate while the bearings still bear that load, the weight. There are two major types of bearings. There are journal bearings and there are rolling element bearings, which we will abbreviate REB. All right, and down here I have sketched each of them. So let's start with the journal bearing so that we can label some of the components here. So a journal bearing has a journal, which is what the shaft is referred to as, and it has a housing, which is this gray color on the outside. The journal bearing also, importantly, has lubricant, and this is what allows for relative motion of these parts without too much resistance. The lubricant comes in some sort of port on the outside, and then it fills this space between the journal and the housing, and that keeps everything well lubricated, lowers friction, and allows for relative rotation of the journal against the housing with little resistance. So main important thing for journal bearings is maintaining that lubricant, making sure that you don't get any debris in there because that might cause damage to the journal and or the housing, which obviously is not something that we want. Next, let's take a look at the anatomy of a rolling element bearing. So a rolling element bearing has a journal also, but more commonly we just refer to this as the shaft. And then the rolling element itself consists of a few different parts. So on the inside here, there's a ring that is fit onto the shaft, and that is referred to as the inner race. And then in purple here, these are the rollers. So this is the primary mechanism that transfers load from the shaft to the housing, these rollers that are moving inside. And then, of course, on the outside, we have the housing, but this is also referred to as the outer race. And the rollers are held in place and kept separated by this component here, which is sometimes referred to as the separator. May also be referred to as the cage. Whatever you call it, it is the part that keeps the rollers separate so that they're not bumping up against each other. It also helps to keep the loading evenly distributed around the bearing and reduces frictional heat. Is a very important component. And then another thing that is not pictured here yet, but is often included in rolling element bearings would be a seal. So that might cover this entire area here on the other side too. And this is really just to trap and keep the lubricant inside the housing. So if you've ever pulled apart a bearing, you would have seen that these rolling element bearings are absolutely stuffed full with lubricant, right? And the advantage to a rolling element bearing is often you don't need to change out that lubricant. It just comes pre-installed inside the rolling element bearing. Now, eventually your lubricant will degrade over time, right? Eventually you'll have surface fatigue of the components inside your rolling element bearing. Little particles from the surface will flake off and act as abrasive element that continues to damage the rollers and the races. But the separator, the seal helps keep the lubricant inside of this race and also helps keep debris and other outside elements out of the rolling element bearing. So it's a very important component. Now, let's pictured here is a roller bearing or a cylindrical type bearing. Roller or rolling element bearings have really two major distinct shapes. One is a ball bearing. So if I replaced those light purple colored cylinders with spheres, that would be a ball bearing. And then what we have pictured is a roller bearing. So how do you decide when you want a ball bearing and when you want a roller bearing? There's a few pros and cons of each. So for ball bearings, we get point contact with the ring raceways. So if you think about the way that a ball bearing is set up, we have balls. I'm going to look at a side view of this. Okay, and these balls are contacting the inner race and also the outer race at points, right? The intersection between a sphere and a flat surface is going to be a point contact, or circular if you get some deformation. In contrast to that, a roller bearing is going to have line contact with the ring raceways. So let's do this. copy this. Right now, let me see if I can draw this in 3D. So if these are now cylinders, they're going to intersect the shaft, or either the raceway on the inside or the outside, along a line. And if we have a little bit of deformation, it'll be rectangular. But in any case, you're going to get a line versus a point. You get more contact area with a roller bearing as compared to a ball bearing. So let's write that down because it's an important point. So you get a smaller contact area. And for the roller bearing, you get a larger contact area. What that means for the ball bearing is that you're going to get lower rolling friction. Remember that friction is proportional to the contact area. The amount of surface area you have in contact between two parts determines the magnitude of your friction, magnitude of the force of friction. And for the larger contact area, of course, you get a higher rolling friction. Okay, now that means for the ball bearing, we can achieve higher speeds. For the roller bearing, the advantage of having a larger contact area is that you can carry heavier loads. Right? We may have more friction, but we also have a larger area that we can distribute our load to. So remember that the weight of whatever is being supported by this bearing has to go through the outer race, through the roller, to the inner race, and ultimately to the shaft, or vice versa. Maybe the weight is coming from the shaft transferred to the outer race. But in any case, it has to pass through these rollers, and so if you have a greater surface area that you can distribute your load to, that means lower stress, which means that you can carry heavier loads. Okay, so for ball bearings, we have a limited load capacity. And for the roller bearings, we have lower speed. So you will see on bearings for trains that they tend to use roller bearings, right? We care more about being able to transport heavy loads on a train than we do about going very fast. But if, in contrast to that, you would rather have a high speed and you don't need to bear too much load, then a ball bearing might be the right choice for that application. The other major factor that we need to consider in selecting a bearing is the load direction. And we can break down the types of bearings into radial or thrust. And there's a whole spectrum in between, but largely radial bearings accommodate radial loads. And thrust bearings accommodate thrust loads, or we might call them axial loads. And the contact angle is what determines whether a bearing is a radial bearing or a thrust bearing. So let me attempt to draw each of them. So for a radial bearing, where the load is predominantly acting in the radial direction with respect to the shaft, we might have a bearing that looks like this, right, where here's the shaft. Draw it on either side. So if our load is predominantly radial, this type of bearing is going to be able to transfer that load. All right, but if instead we have an application where we have a lot of thrust load, we might need a thrust bearing which has a contact angle closer to 0. And to install these, you might need to have a shoulder on your shaft. So that it has something to press up against. But now if we have a thrust load acting in the axial direction of our shaft, this bearing is going to be able to transfer that load. Okay, and then there's a whole spectrum in between where we have, bearings, say at a 45-degree angle, and they might sit, in a race that looks something like this. And these types of bearings can accommodate both radial and axial. So depending on the angle, let's write this out. The contact angle determines if a bearing is radial, which is the case if your contact angle is less than or equal to 45 degrees, or a thrust bearing if your contact angle is greater than 45 degrees. Okay, so if I draw the angle of this bearing here, That looks like it's less than 45 degrees to me. Maybe this is about 30 degrees, which means that this is a radial bearing. So it will predominantly carry radial loads, but because it is at an angle, it will be able to also transfer some thrust load. All right, and later on in the series, we will get to combined loading and how to estimate bearing life. But in the upcoming video, we are going to start talking about contact, because the primary mechanism for load transfer in rolling element bearings is contact. So we're going to go through some Hertzian models, and then we will discuss surface fatigue a little bit, and then later on we'll talk about journal bearings too. But for the next few videos, we're going to be focusing on these rolling element bearings. All right, so I hope you enjoyed this video as an introduction to the topic of bearings, and I hope to see you in the next one.